Okay, so key to this, again, there's two things key, that you fill the whole thing in. My advice is, my advice is, put parentheses around any x that exists there, and then replace that with the x plus h. Be careful on this minus sign. Use parentheses because you've got to distribute it. Yep. Yep. If there was another x, I'd put it in the other x also. Because if I gave you this, and I said f of 2, what would you do with the 2? Both x's. So whenever you see x's, go like this. So if you'd put 2 in there, if this is my argument now, put x plus h in there. That's the easiest way. I think just one more. I gave you 2 of them. Yeah. I didn't need you to do all 3 because they're the same. Now this one had 2 x's. So again, if I gave you f of 2, you would put a 2 in here, you would put a 2 in here. So if we give you f of x plus h, make sure then you put in x plus h in here and x plus h in here. And again, watch that minus sign. If you find that you can't eliminate something that doesn't have an h, it's probably because you put it in wrong. You didn't negate it or something. Or you didn't FOIL this guy. Another bad one is x squared plus h squared. And I still see it in pre-calc honors. So be careful. Make sure you FOIL that out. Again, your goal is to eliminate the h. In calc, you're going to see this. As h approaches 0. Eliminate this. I know I can't use a 0, but I can eliminate it and see how close I get. And if you remember back in September, when we were graphing things, God bless you, when we said, what would this point be? We looked at the graph and we did like, if you remember, I did like 1.0000001.99999. We did them like that to see where they would approach. That is what your limits do. So next year you'll work a little bit more with this. Good? Questions? You like them? You'll probably see one. These are nice. This one's the big one, guys. And I don't know what happened to my word. I honestly don't. When I pulled this up yesterday, I was like, what the heck happened? I think the word on this one is far more advanced than my word on where I wrote it, so I have no clue. I have no clue. You know how sometimes it writes over my things, it's writing over it, it's just like, I don't know what happened to it. But we'll get through it. We'll get through this. Okay, there were 2 things to do here. I gave you 2 things. And if you want, I mean, I can do this over if this is not doable. Yeah, it's funny because when I print it prints out fine. Where's my printer? Oh no, it didn't print out fine. I didn't even look at it. It didn't print out fine. It happened in not all of this, just parts of this. I'll tell you what, can we do the rest and then save one for later? All right, because the rest of this looks okay here. Not this one, but okay. This is one of the big traps also. Finding the domain for this guy. This is a quadratic. So be careful. What we did before was we said we have 3 domain restrictions. 1, we can't have a 0 in the denominator. 2, we can't have a negative under a radical. And 3, we can't have a negative or a 0 if the radical is in the denominator. So this happens to be in the denominator. So we take this guy and we set it greater than 0. Okay, now, it's not as easy as solving just an equation with an inequality. If you remember, we factored this and we set this equal to 0 and we found the factors. Don't switch these around. Factor them like this. So the square root This is your perfect squares. The square root of 625 is 25. Two terms separated by a minus, see if that's a perfect square. So my factors are plus or minus 25. That doesn't mean that's all I can use in there.
It's not under the radical.
Well, we took it out under the radical because now we're going to say we can use anything above a zero. We can't use a zero, we can't use a negative. So we need to see what can we use. From here, go to your number line. If you want, put this in your Y1 and separate this. And see where is it positive and negative. To the left of this guy, it's going to be, it's going to look like, if you drew this graph, it's going to look like this. To the left of this number, just pick any number. Just look for the value of positive or negative for y. It will have a negative y. In the middle, look for the 0. It will have a positive y. To the right, look at the 26, 27. It will have a negative y. So now, which ones do I want? I want the greater than 0. These are critical also. If it's been a denominator, I can't use 0. So these have to be open. And do you need your calculator to do that? No, because this is a quadratic, and which way does it open? Down. So these are my roots, my zeros. So my quadratic would go like this. So doesn't it make sense? This is where the plus is. This is where the minus is. So in here is all my allowable domain. And I can't use negative 25 or 25, so I have to have a open bracket here. So where is it? It's this guy, D. I don't know where it's circled, but it's this guy. From negative 25 to 25. And can you try them? You can absolutely try them if it's a multiple choice. My advice on the multiple choice, because I'm against multiple choice, but my advice is solve it first. And then plug it into your calculator and see if it works. Okay, obviously 25 is a cutoff. So whether I use 25 or I don't use 25, or I use the outside or I use the inside, pick a 0. Pick somebody in the middle here. If the 0 works, then I know I'm one of these guys. And then try 25. 25 won't work because it's a 0 in it, in the denominator. Okay, this guy down here, and I don't know where this black box came from. It's so weird. All right, end behaviors. End behaviors are your asymptotes. It's just not working out. All right, maybe we could see 3 from there. Or maybe not. I honestly don't know what's happening. I'm sorry. Anybody have a suggestion? I mean, we can do them all out. The idea is I don't want to do them all out. It'll take us forever. And you have them done. Ah, got it. Okay, end behavior. End behavior are your asymptotes. Where are my ends going on this graph? A good way to do this is graph this guy and see where your end behaviors are. Okay, this one has a slant asymptote. If you remember, we had 3 rules for checking your asymptotes. Well, for your horizontal asymptote. Horizontal asymptote is going to run your end behaviors. So we had 3 rules. We said if the power in the numerator is less than the power in the denominator, you had y equals 0. If the power in the numerator is the same as the power in the denominator, then you have a y equals and you make it a ratio. Remember these? Do you have to? They're in your packet.
Like on my test.
Yeah. They're in your note packet. If you look, you know your one where I gave you the formulas? They're in your formula packet. I put them in there. Did you look at your formula packet? And then the third one is, if the new power in the numerator is exactly one more than the power in the denominator, you have a slant asymptote. Remember those? So this one had a slant asymptote. So all we're asking you to do is synthetically divide it. So you're synthetically dividing it and you're getting rid of whatever remainder you have. So underneath this should say -2, 7, and 8. -8. This you don't care about. Because this is x2 over x1, this guy's an x. And there's your equation for end behavior. Okay? It's a slant. Graph these. You want to see what these look like. And you can graph that line in your graph and see if your graph is following that line. If it crosses over it, something went wrong. Did I give you 4?
No.
I took out 4? Okay. Did I give you 5?
Yeah.
I can mark down the ones that I crossed out. These just had a lot of finding end behaviors, finding asymptotes, because that's really important. We spend a lot of time on that, and the very fall probably.
We're going to be able to use our calculator.
Absolutely. Absolutely. Okay. So which of the following is correct for this graph? Okay, so you're gonna factor and you're gonna reduce this. Your vertical asymptote, you have to factor this first. So what are factors in the numerator? I don't know where the answer key is to this. I don't know where the answer showed up. It shows up on mine. It shows up on mine. I don't know where it is. And this is x minus 4, x minus 2. Now, domain restrictions come from your denominator. So we're looking at a domain. I can't use 4, I can't use 2, right? The asymptotes are different. Remember we said factor, and then cancel out whatever factors you have. Your common factor, when I cancel this out, I still can't use 2. But it doesn't become an asymptote. You remember this becomes a point of discontinuity? This is my point of discontinuity. So what I'm left with is this. Now, this is my vertical asymptote. X is equal to 4. Okay, so it has a vertical asymptote at x is equal to 4. So this one's wrong. It has a horizontal asymptote. The power in the numerator is the same as the power in the denominator. So we make a ratio. So our horizontal asymptote is going to be y equals 1 over 1, or 1. So this guy looks good. Okay, your y-intercept is when x is 0. So out comes this, and I'm left with 6 over 8. And that reduces to 3 over 4. So A and B are true. Yes. The horizontal one, if you look at your formula sheet on the second page or so, there's 3 things to find a horizontal asymptote. It has to do with the highest exponent. So if the highest exponent is the same in the numerator and the denominator, you take their coefficients and you make a ratio. And it's a y equals. If it's less than the denominator, then your horizontal asymptote is y equals 0. If it's greater, we don't have a horizontal unless we have exactly one more, then we have a slant. Those 3 are in there. And those 3 are what we use for limits as well. When we call something by a limit, and we'll fit that in a second. Yes.
So, for the line percent, you just took out the 1 to 6.
Well, yeah, because when you're looking for something that crosses the y, x is equal to 0. So I just, if I plug zeros in here, I eliminate all those. Okay. I didn't give you 6, right? No. Because we don't really need to do 6. It's just finding the highest y value. Look, I'm up again. I don't know why this happens. I'm sorry. I don't know what's going on here. I've never had this happen to my board. Of all the things that goes on with this board, this didn't happen. Alright, so we don't have 6. Hang in there. Uh-oh.
Looks like everything stopped.
I don't understand this. It's back. Okay. Yeah, but it's also not giving me my answers either. My answer page, I have things written on here, trust me. Okay, so again, this is the same thing. And my advice, guys, is graph this. Always graph these things. This is x minus 7, x plus 7. This is x minus 7, x minus 1, right? Okay, so this that comes out is called what? Point of discontinuity. So x is equal to 7. To find the other part of that, do you remember how we just took this and plugged the 7 into here? I can't plug a 7 into this. So let me show you something. If I say find the limit as x approaches 7, you would say, I can't plug a 7 in there, right? Because I get a 0. So what happens is, this is an open point. It shows in your table as I can't use it. But on my graph, it looks like that's why I say graph it. Because it looks like the point is there. This is called the removable point. Remember we did this back in the fall. So this is removable. And how do I get around it? I factor, and then I take this, and then I plug the 7 into what was left over. So 14 over 6. And if I reduce this, it's 7 over 3. So my point of discontinuity, if I could fill this in, would be this. I heard it. Oh, so you remember back, right? Yeah. We remember doing this. It was probably like October, I'm thinking. Right? It was a while back.
So it said like x over here.
Because you're going to see this in calculus. You're going to see it written this way.
Oh, so not for this test.
As for this test as well. You're going to see 2 of them. And I'm going to go over them on the limits page, but I'm just going to call it the limit while we do this.
Okay, but so if it said x, when I x out, like 8, would you subtract 8? Would you put in
8 I can use. 8 I can just substitute 8 in and I can tell you what my point is. It says 7 because I can't plug a 7 in here. 7 gives me a 0. I can find the limit to any point. If I say x is, as it approaches 2, I can plug a 2 in there and tell you what the point is. You can tell me from your table as well when you graph it. So now, it has infinite discontinuity. It has a point discontinuity. We know that. So it can't have no discontinuity. In infinite discontinuity, it just means that it just jumps and it doesn't continue at all. But we have continuity here, so don't worry about this one. I don't ever see it written like that either. But this one has a point discontinuity. Did I give you 8? Here. Trying to get 12 as fast as I can. 8, 9, and 10. Okay, thank you. Okay, 8. Oh, 8. I want to do 8 because it's a synthetically divide. All right, let's do 8 because I can't move this, but let's do 8. All right, so you're synthetically dividing this. So you're going to take out all your leading coefficients. So you're an x5 over an x2. So 5, 4, 3, 2, 1, 0. Make sure it works. Your denominator says this. Okay, the leading coefficient has to be 1, which it is. So if I have 3 terms, I take this out the opposite way. I take this out the opposite way. Probably did this like back in the fall also. Yeah. Okay, so now watch. If you have trouble, just watch first. Same as you synthetically divide. We pull this down. We start here, we multiply, we go to the right. But we have another one here. Then multiply, we go to the right of that. Stop and add this guy down. Good? We're just going to repeat this process. Normally you say multiply, go to the right. We do the same. We take this then, we just have one extra to do. Multiply, go to the right. Stop and add this guy down. Do it again. 3 times 4, go to the right. Negative 5 times 4, go to the right. Stop and add this one down. Negative 5. Yep, negative 5. Negative 5 times 4 is negative 20. I'm over here. Now, 3 times negative 5, negative 15. Negative 5 times negative 5, 25. When you're at the end, just add everybody down. So this becomes negative 30, and this becomes 22. Now, your x5 over x2. What's my leading power going to be? x3. So x3, x2, x1, x0. This is your remainder. Work it backwards. x0, x1. So I've got x cubed plus 3x squared plus 4x minus 5. Here's my remainder. Negative 30x plus 22 over my denominator. Okay? It's a double one. Number 10, the asymptotes, did you get C? C for number 10? So when you factored it, what does it factor to? X minus 3 over number 10. X squared factors to x minus 3, x plus 2. Take out your point of discontinuity. This guy's your vertical asymptote. So what's your vertical asymptote? X equals negative 2. And so the top one, x2 over x2, this is your horizontal. They're the same, so y is equal to 1. So you have 2. Choice C. Use those rules, guys. I put them on your formula sheet for a reason. I didn't give you 11, right? Well, that's a good one. You had 9? Did I do 9? Oh, now there's synthetic division? Yeah. Okay, work on 9 tonight. We'll check 9 tomorrow. Let's hit 12. Let me see if I can pull up 12. I honestly don't know what to do about this. Very weird today. Weirder than it normally is. All right, let's do 12. Okay, so you put this in your graph. You had something that looked like this. It's crossing through the 0, 0. Of course, my board is off as well. So give me a sketch. What's your domain? All real numbers. Intercepts. You need to show me your intercepts algebraically. So what do I mean by that? Plug in the zeros. When x is equal to 0, when y is equal to 0. When x is equal to 0, what is y? Absolutely. Just show me the substitution and say y is 0. When y is equal to 0, what do I have to do to this guy? Factor it. So what can I factor out? Okay, let's take out a negative x. These guys, my perfect squares. So x is equal to 0 and x is equal to plus or minus 2. Remember doing this? This is my highest exponent. I should have 3 zeros, God bless you. 3 zeros, minus 1, 2 terms, minus 1, 1, what do you call that? I didn't ask you for it, did I? One, oh my gosh. Oh my gosh. Inflection point. One inflection point. Thank you. I just completely drew a blank because I'm thinking and talking at the same time. Okay, so maximums and minimums. Label these guys. This is my maximum, this is my minimum, this is my maximum. What do I call A? Just a minimum? A relative minimum. And B is my relative maximum. Put it in your calculator. How many decimal places do I need to go? 3. So your relative max is, I can't even read this because it came out weird. 1.155, it looks like that. 3.079. So we have symmetry here. This must be negative 1.155. Negative 3.079. Okay. My range, what's my range? All our numbers. And remember doing increasing, decreasing? Do we go by the x's or the y's? The x. So, like a roller coaster, I'm decreasing from here to this x value. I'm increasing from here to here. I'm decreasing. But inflection points. I don't know if you have an inflection point on your final, but this would be where my inflection point is. Halfway between. How do I find, because if I'm concaving, it's only going to affect your concavity. I don't think this asked you concavity. But if it's concaving, this is concaving up to this point. Find the average of your x's and then plug in your calc and you'll find the average of your y's. I think it comes at the 0, 0 because this is symmetrical. So this should be, think of that at the 0, 0. So I'm going to concave from negative infinity to 0 up, and I'm going to concave down from 0 to negative from 0 to infinity. Remember your concavities, they work off your inflection points. So that should be that. What's the next one I gave you? 14? 14? 15? Oh, okay. This one's a good one. Okay, this one's a good one. Let me just start you off because we'll finish this tomorrow. Okay, what you have to do is, how many roots should this have? 4. Look in your calculator and find 2, and then start synthetically dividing until you come down to a quadratic. Remember that? Okay, so tomorrow work on what number? We'll work on these, but what number, what sheet do we do tomorrow? Tomorrow, do 6, guys. Make sure 6 is done. We'll go through the rest of this, 5 and 6 tomorrow. I don't think 6 is bad. One's a little short, because I think you only have like parametric in it. Yeah. Crossed up everything else. You too, thank you. I would have a better day if I knew it was probably this. I'm sorry about this, guys. Oh, good.